the Hertzsprung-Russell diagram. It was developed by N.J. Hertzsprung and Henry Russell in the early 1900s. It's providing the primary insight for stellar astrophysics. It is also used to either summarize the evolution of stars or to find the properties of stars, such as their age or their elemental makeup. This is done through the comparison of the X and Y axes, the X-axis being temperature measured in Kelvin, and the Y-axis being luminosity, which is measured in solar units. Solar units are derived from the luminosity measurement of our sun, which is measured at 1.
Okay, so here we have the Hertzsprung-Russell diagram and main sequence stars. They vary in all types of temperature and luminosity all across the board. These stars, they contain about 90% of all the stars in the universe are going to be main sequence stars. They live for about 10 billion years just in this phase alone. Okay, so these stars undergo fusion in their core. What that is the hydrogen atoms will combine into helium.
An example of a star off the main sequence would be the red giants, which are low in temperature but high in luminosity, meaning the star is large and bright. These stars have exhausted their hydrogen fuel and are now burning off their helium fuel. An example of this would be Betelgeuse. So another example would be the white dwarfs, which are high in temperature but low in luminosity, meaning the star is smaller and harder to see. These stars are in their final stage of being a low mass star. An example of this would be Sirius B.
As you've heard, we can use HR diagrams to look into the lives of stars that have been around longer than humanity itself. We can trace the evolution of stars from when they begin fusing hydrogen on the main sequence, all the way through the red giant phase, and for low mass stars like the sun, around into white dwarfs where they will slowly cool into dimmer and dimmer objects. The diagram also shows us the limits of star formation. At the cooler end, past the cooler stars, there is not enough temperature in the core for fusion to begin. And at the hotter end, up here, there's interactions between pressure and gravity that cause the upper limit on the brightness of stars.